From the medicines we take to the lotions we use, pretty much everything is made in a factory. But what if those factories could work less like giant, clunky industrial machines and more like, more like nature? We're going to dive into this amazing new world called biocatalysis, where these tiny, natural powerhouses called enzymes are completely changing how we make, just about everything.
So let's start with this big question. What if our factories actually worked like nature? Instead of just brute force, imagine a factory floor powered by a whole toolkit of these elegant microscopic machines, enzymes. These are being designed in labs to build the complex molecules we need. It's a massive shift from old-school industrial chemistry to a smarter, biological way of doing things.
Now, to really get why this is such a game changer, we have to look at the problem with the old way. For more than 100 years, manufacturing has been, let's be honest, a pretty dirty job.
Okay, this is a perfect example. Think about emollient esters. That's the stuff that makes your lotion feel all smooth and nice. The traditional way to make them is pure brute force. You gotta crank the heat up to over 180 degrees Celsius. That not only wastes a ton of energy, but it creates all these smelly, discolored impurities that you then have to bleach out. But look at the enzyme process on the right. It's so much more elegant. It just hums along at a gentle 60 to 80 degrees, and you get a pure, clean product right from the start. No mess, no fuss.
So, if brute force chemistry is the problem, it turns out nature already has the solution. Let's meet the heroes of this story, nature's own microscopic machines.
The whole field is called biocatalysis, and it's pretty much what it sounds like, using biological catalysts, enzymes, to make chemical reactions happen. I mean, these are the tiny proteins that run literally every single process in every living cell. And now, we're finally figuring out how to harness their incredible power for ourselves.
So what makes these little guys so powerful? Well, for one, they are incredibly specific. An enzyme is like a perfect key for one single lock. It only targets the exact chemical bond it's supposed to, which means you get way fewer unwanted byproducts and a whole lot less waste. Plus, they work in gentle water-based environments, which slashes energy costs and is just so much better for the planet.
But here's the thing. Nature doesn't always have the perfect enzyme just sitting around for every single chemical reaction we can dream up. So scientists got clever. They figured out a way to give nature a little nudge. They're basically training an entire army of enzymes to do our bidding.
And the main technique they use is called directed evolution. Seriously, it is evolution on fast forward, but right there in the lab. Instead of waiting millions of years for an enzyme to adapt, scientists can guide its evolution in just a matter of weeks to make it faster, more stable, or even get it to do entirely new tricks.
And look, this isn't just some clever lab trick. This is a world-changing innovation. The pioneer of this work, Francis Arnold, actually won the Nobel Prize in Chemistry for it back in 2018. That's how important this is.
So how does this enzyme bootcamp actually work? Well, first, you take the DNA for an enzyme and you make thousands of slightly different copies, each with tiny random changes or mutations. That gives you a huge library of new enzyme variants. Then you test them all to find the one that's just a little bit better at the job you want it to do. You take that winner and you do it all over again. Mutate, screen, and repeat, getting better and better with each round.
Okay, all this might sound a bit theoretical, but its impact in the real world is absolutely profound. So let's look at an amazing case study of how this technology helped create a life-saving medicine.
Right, so this molecule right here is Sitagliptin. It's a blockbuster drug for type 2 diabetes. Now, you don't have to be a chemist to get the big picture here. A really critical step in making this drug is adding that little amine group, the NH2, in exactly the right spot. The problem was, the enzyme scientists first tried was totally useless for the job. It just didn't work.
So the team at Merck used directed evolution to create a brand new custom enzyme. And check out the before and after. The old way, on the left, used a rare, super expensive heavy metal and needed all this higher pressure equipment. The new way, on the right, uses their engineered enzyme in simple, mild conditions, no high pressure and no heavy metals. It's just a cleaner, simpler process.
So, what did this new, greener process actually achieve? First off, a staggering 53% jump in overall productivity. That means making more medicine more efficiently.
And it wasn't just faster, it was way cleaner. Because the enzyme was so precise, it delivered the final drug at an incredible 99.95% purity. That means you don't need all those costly and wasteful extra purification steps.
And this is maybe the best part. It was a huge win for green chemistry.
The new process completely got rid of the need for that toxic heavy metal catalyst. That means less hazardous waste and a much safer, more sustainable way to manufacture, from start to finish.
Now, the Sitagliptin story is a huge deal, but honestly, it's just the beginning. This third wave of biocatalysis is really about to change the future of how we make, well, almost everything.
Yeah, this isn't some niche technology just for pharma anymore. It's being used across a massive range of industries. We're talking about the natural flavors and fragrances in your food, agrochemicals for farming, specialty materials, and even huge-scale bulk chemicals. Enzymes are quickly becoming the go-to tool for modern manufacturing.
And that brings us to one last kind of mind-blowing thought. We've seen how enzymes can build these really complex things with surgical precision, but what if we use them to unbuild things? The next big frontier is engineering enzymes to break down really stubborn stuff, like plastics, and turn our waste back into something valuable. The factory of the future might not just be greener, it might actually help us clean up the mistakes of the past.